Hey, afternoon. What is it now? Good afternoon, everyone. My name's Daniel Lumi. I'm a senior product manager at Off-Chain Labs, working on Arbitrum Core Protocol. And today I'll be your moderator, and we can continue with a quick round of intros.
Hello, everyone. This is Michael from Brevis. We work on verifiable computing, and among other things, we have a ZKVM product called Pico, and right now it's on ETH proof, and the fastest ZKVM on GPU proving for a single GPU, and it's a fully open source, and we have a lot of integration with many DeFi protocols, and the partners happy to kind of talk more in this panel as well.
Hey, Justin from ETH Proofs. We're trying to have as many ZKVMs as possible prove the L1 mainnet and have the validators verify the proofs that are generated instead of re-executing blocks, and therefore allow us to dramatically increase the gas limit for Ethereum L1.
Hey, Mohsen here from Zircuit. Zircuit is a ZK rollup, and we use AI to detect hacks at the mempool level before they happen, and we take actions immediately to protect users. Excited to be here to discuss ZKVMs.
And I'm Florian from Linea. So Linea is a ZK VM. We have a different approach from many other VM because we are doing direct hermetization of the EVM, and we just released a 100% version of the EVM a couple of weeks back, and looking forward to participate in L1 proving.
Cool. So let's start with an easy question. At least for this crowd, I think it'll be people will have context on it. But how will ZKVMs, generalized ZK virtual machines, affect the future of scalability for Ethereum L1?
Justin, you might want to take this one.
Yeah, I mean, as I said, the hope is that we can have both scale and decentralization. Traditionally, we haven't been able to dramatically increase the L1 gas limit because we want validators, consensus participants to run on commodity hardware. The meme is Raspberry Pis, but in practice, you need something like a laptop. And the hope is that with ZKVMs, we can easily snarkify the L1 with two things. One is client diversity, right? Because we're assuming that every ZKVM is buggy, every execution layer client is buggy, and so we want to be able to retain the diversity that we have with the execution layer clients and basically compile them to multiple ZKVMs so that we have this diversity. And the second thing that we need is real-time proving. And one of the things that we found is that with ZKVMs, you can reuse a lot of the existing technology around compilers, and you can optimize just one thing, which is fairly simple, which is this minimal ZK-friendly ISA, and then it just turns out that the numbers are good enough to get real-time proving on a cluster of GPUs that could potentially be run from home. So we're in a fantastic position to get both scale and decentralization using ZKVMs.
Yeah, just to add on a little bit on that. So traditionally, if you look at all the blockchain kind of networks and blockchain in general, blockchains are built on consensus. And consensus is a process for a decentralized network of validators or miners to achieve the same outcome on certain program execution. Right, so traditionally in the simplest form of computing, how you can actually achieve consensus among nodes is through communication protocols, of course, but most importantly, re-execution of the computation itself. One node executed the block saying that, okay, this guy transferred this guy some fund. All the other node in the network wants to kind of re-execute this kind of computation. This is fundamentally why layer one blockchains themselves are fundamentally going to be pretty expensive, because right now, everything's running on this kind of replicated computing, the replicated storage mode. And ZK really introduced this new paradigm of verifiable computing that allows you to just have one guy among this hundreds and thousands, even millions of validators to execute the computation, and then generate a very, very succinct and easy to verify proof and send the proof to all the other validators. Then, in this case, all the other validators doesn't actually need to repeat the very expensive computation itself, but just to verify the proof itself. So what this means is that it really increased the possible kind of scalability ceiling for layer 1 Ethereum blockchain, because now you can have like one guy that is running extremely fast proving for very complicated, like 10 times, 100 times, gas limit, blocks, and then just generate a very, very succinct proof to let all the others verify the proof, like with a tiny fraction of the cost of execution, right? So like that's why we feel that this is extremely exciting to kind of have ZKVM be part of the future layer 1 Ethereum scaling roadmap.
So I think that's a perfect answer, honestly, for how does ZKVMs benefit Ethereum L1? It allows you to actually have the verifiability of blockchain while scaling. Let me ask a cheeky question now. When? When will we have ZK for execution clients on L1? When will we have Beam Chain? And I know, Justin, you don't like this question, but just to put some like realistic expectations to try to understand what are the bottlenecks of getting there, and how soon can we, optimistically expect to be there?
So one of my personal goals for 2025 is to run my validator from home using ZKVM. So I would get rid of my external hard drive, which is an NVMe drive. I would run fully statelessly. And if I want to be like really extreme, I can get rid of my laptop and verify EVM blocks on a Raspberry Pi Pico, which is a $7 piece of hardware, like the next level after the Raspberry Pi. But the main trade-off here is that I'm going to have to wait for the proofs to come, and the proofs come in they take about 12 seconds to come, so one slot, which means that when I attest, I'm going to be attesting with a 1 slot delay, and I'm going to be losing on what's called the timeliness rewards. So a small fraction of my APR is going to be sacrificed. But the good news is that I might be making more money by not having to buy a new hard drive and not having to spend all of this electricity versus what I stand to lose from my one validator. Now, of course, for ZKVMs to be really production ready, we don't want people to attest with a 1 slot delay. And so there's this hard fork, which will probably, in my opinion, come in 2026, called delayed execution, which means that you have a whole slot to do for the proofs to arrive, and the validators still get their full rewards. That, again, I'm hoping will happen in 2026. And at that point, anyone who wants to can opt in and still get all of the rewards. And then there's this phase in 2027 where the proofs would have to be mandatory, where as a block builder, you have to generate the proofs, otherwise your block is not considered valid by the network. And here things become even cleaner and even more powerful.
I think this gives us a challenging timeline to be ready to be able to generate this proof in very short amount of time, because 12 seconds would work for delay proving, but for real-time proving, it's still too much. And also, initially in the first answer of the first question, it was mentioned that an important aspect is decentralization. So it's really important that even though we can generate proof in, let's say, 2-3 seconds, it's important that many people can do this in 2 or 3 seconds. So it's very important that the cost of generating this proof is affordable, so that it's not centralized in a couple of provers.
And on the topic of costs, we did not a few years ago think it would be ever possible to have cost-efficient generalized ZKVMs. It was always theoretically possible, but it could be really expensive. So now we've seen it got way cheaper. RISC-0 innovated on that a lot. And we got to this age of where everyone's building a ZKVM right now. And that comes with a small performance overhead. There might be a lot of applications that work for that, but for custom applications, it might not. So the sort of question is, are we going to reconsolidate our ZKVMs or custom circuits? And I'm curious, Florian, as well, because Linea runs a ZK EVM, not a ZKVM, of do we, in the future, at large scale, with corporations or large scale rollups, will we have generalized ZKVMs or custom coded virtual machines or circuits?
I believe there is room for both. Maybe the biggest share will be for generalized one, but I strongly believe that specialized circuit will still bring value, especially for complex systems that have strong performance requirement, because having a direct arithmetization of the EVM allows us to generate traces that are much smaller than if we had this virtualization, these extra layers on top. And also it allows us, or it will allow us to do formal verification without having to verify the compiler. So I believe that it has assets that will make this approach meaningful.
So on the approach of whether generic or specialized circuits, I must say the way Ethereum works, and we as rollups, we see that, there are new EIPs coming in, and I see this specialized circuits as a huge technical debt that we have dealt with. EIP 7702 was a gigantic pain to actually port it back into the circuits that we had and implement everything over. So although I see performance gains that we could have with specialized circuits, so I do see the point, but I think these generic VMs enable us to keep up with the pace that Ethereum moves and do the formal verification at the level of the VM, do it once well, and make sure everything is sound and everything is perfect and move on forward.
Yeah, on this topic, right? So like, generality versus like, specialized circuits. In fact, today, every ZKVM available on market contains a bunch of, specialized circuits in them. And, it's not really like really just like RISC-V instruction set. It's not only that. You actually have a lot of specialized circuit to handle certain kind of workload with hash functions, signature verification. These things are called low-level precompiles that allows you to accelerate a certain kind of a workload that would be very slow to run on generalized ISA-based kind of a ZKVM. Now, for us, like at Pickle and at Brevis, like we build Pickle as an extremely modular ZKVM, and we take the idea of kind of this modularity and push it to a new level. In Pickle, we treat the Pickle itself just as a glue for the computation, for verifiable computation, and we plug into this glue a lot of something called coprocessors. Like precompiles are considered a low-level coprocessors, but we actually take a step further to plug in some application-level coprocessors that handle a huge chunk of application business logics. Let me give a very, very concrete example, right? So for example, we have something called a ZK data coprocessor that allows developer to use an SDK in the ZKVM in Rust language to say, okay, now I'm gonna handle a special kind of a workload or business logic where I want to access historical Ethereum on-chain layer 1 data, such as users, transactions, states, and events. Right, so what you can build with this is like a lot of things, like trading volume-based fee discount that we launched with PancakeSwap and many other DEXs and Uniswap in the future as well, to enable user to generate a ZK proof showing that, okay, I have traded this much and I should be getting a dynamic fee discount going forward. Now, for this kind of a workload, if you implement it directly in ZKVM, even with precompiles, it's going to be insanely expensive. So we actually kind of offload this into a specialized coprocessor and specialized system to handle this kind of thing. And we feel this is going to be the future trend as well. I think a lot of like teams, even in the real-time ZK, proving of layer 1 blocks are thinking about implementing and taking some portion of that workload into specialized coprocessor as well. This is also something we are looking at. So, I think in the future, this is really going to have to be a combination of those, and a very kind of a well-structured ZKVM architecture, like with a strong modularity, is something that we need to kind of achieve that.
That leads well to a different question. So for large the reason why RISC-V is used as the backend for most generalized ZKVMs is purely simplicity, right? RISC-V has 56 opcodes, easy to make a ZK prover for. But there are other teams that are implementing with custom ISAs or WASM or MIPS-based proving of. In this group, do you see RISC-V as the future of ZK proving for L1, or will there be varied approaches through different ISAs or virtual machines that we could use?
So ETH-proofs is trying to answer this question, and ETH-proofs call numbers 4 and 5 will be debating this. So on call 4, we're going to have the pro RISC-V people, and then in call 5, the alternative to RISC-V. What we're seeing is that there's this power law distribution. About 2/3 of the ZKVMs are RISC-V, and then of what's left, there's a little bit of WASM, and then there's basically lots of ISAs that just have a single representative, especially the from scratch ISAs. Now I expect it to be a very lively debate with lots of strong opinions, but what I think needs to happen for the people that are advocating to not go with RISC-V is they need to band together, because right now there's just way too much fragmentation in order to get anywhere. And one of the things that we're hoping to do potentially in the medium term of Ethereum is have a ZK-friendly ISA exposed under the EVM, so that first of all we can potentially deprecate the EVM or freeze it and not have to maintain it anymore and just have the simplicity of the ZK-friendly ISA, but also allow smart contracts to directly run on the ISA and therefore not have to pay the cost of the EVM emulation.
Maybe I want to add one point here. I think it's also important to keep the diversity the same way we have client diversity implemented in different languages. I think it's important for the safety of Ethereum to keep some openness and not to force everyone to use a given ISA, but to keep the possibility to write ZK proof differently. That will ensure that there will be no one bug that will affect all proving system.
Yeah, just speaking from the RISC-V camp here, I think if we're being very honest with ourselves, like for all the RISC-V folks, we're not actually implementing RISC-V ICs. Yes, we are RISC-V IC compatible, but there are tons of other stuff that we plug in as pre-compiles, like as co-processors and stuff like this. So, to be honest, like everyone today is running on some exotic ISA, basically. And, the way we see this is like we are completely not objecting to kind of incorporating new ZK-friendly primitives in the instruction set. And the reason we actually kind of build with the RISC-V based ISA is, of course, it's open source, it's simple, but most importantly, it's the tool chain is very complete. We started building, when Brevis first started, we didn't have a ZKVM, but we started building ZKVM around last November, and now we're kind of already pretty fast in terms of like performance and everything. The reason that we can actually achieve this, and now proving ETH layer 1 blocks, is because there is a very complete toolchain that allows you to very easily have the compiler, architecture plug in this kind of new things as the SDK or as system calls to kind of make this thing work really fast. And however, in the future, I do think that the optimization and the performance optimization is going to come in all directions, and ISA modification and improvement is definitely an area of focus for us as well.
So going back a little bit to the cost efficiency question behind ZKVMs, I think for a long time, we as the ZK community kind of expected that custom hardware acceleration of ZK proving would be required to really get cost efficient. But it's crazy how fast this space moves. So like ZK Sync's new prover is 4 4090s for real-time proving SB1, and RISC-0 are like 32 4090s, right? So is there still a future for hardware-based acceleration? How important is it to have these kind of ASICs or FPGAs to accelerate ZK? Is it going to only really matter for Web 2 use cases, or is that also something that we should really be paying attention to on L1 and L2 level?
So I'd argue that cost is definitely a solved problem. Proving an L1 block today costs about 3 cents if you go to ethproofs.org, and the cost is going to keep decaying exponentially. the real bottleneck now is power. So we don't want to depend on data centers. We want the ability to have on-prem proving, either in an office or a garage or someone's home. And the mental model that we have here is that there's tens of millions of people out there that have electric cars, and so an electric charger is kind of a good baseline. And if you take the Tesla home wall charger, it's 11.5 kilowatts. So we're limiting ourselves at 10 kilowatts. Now, this is something that we can achieve today, thanks to amazing technologies like Airbender. But once we increase the gas limit, we're going to have to just keep on optimizing, especially if we want to increase the gas limit to 1 gigagas per second, which is where I hope we will be, which is 600 times more than where we are today. Now, of the 600x, I imagine that at least 10x can come from software improvements. So we only need to find another 60x. And I think hardware is a big part of the answer here. If you had asked me 2 years ago, I would have said hardware will provide 100x, but actually the GPUs have just proven to be so good and so efficient that now I'm thinking that the delta between ASICs and GPUs is actually a bit lower, maybe only 10x. Now, if we take this kind of conservative assumption that ASICs only give you 10x and software only give you 10x, then how do you find the final 6x? That might be through distributed proving. So we could have multiple clusters controlled by different people that are collaborating on one proof.
I mean, in terms of scalability need, for sure, Justin has talked a lot about kind of a 1 gigagas Ethereum. That's kind of a very, very strong need for that. But also ZKVM and generally verifiable computing in general enables a new class of application on blockchain that was not possible before. So another very concrete example that we're building with our partner is trust-free perp DEX with Web 2 level UI. Right, Web 2 level user experience, with privacy protection. Basically, you can build with ZKVM, the capability to have an order matching engine that is matching order in real time, and then batch these orders and generate ZK proof of the matching result, and then kind of have committed the state root for this specialized application about what is user's available balance, but at the same time provide additional privacy benefit to hide the actual user position and the actual open interest and stuff like that to make sure that the kind of a liquidity assassination happen on kind of a hyperliquid doesn't actually happen in this kind of dark pool based perp DEX. And for these kind of application use cases, the demand for scalability is actually quite insane. However, the good news there is for this particular case that each and every single transaction, which is just like a particular trade or swap or order placement, is actually pretty simple. So this is where we can actually use a strong parallelization to solve this and reduce the latency to a kind of a minimal amount and to an acceptable amount. But again, it comes back to the power, thing that Justin mentioned, that we want this to be kind of a pretty cost efficient, also in the power consumption side of things, and also at the same time kind of maintain the same level of user experience possible. So there are a lot of different kind of application use cases where you can put most of the computation logic off-chain and just use Ethereum layer 1 as the settlement layer and as kind of the asset management layer. That would be possible with ZKVM as well.
So I promised I would ask two kind of spicy questions. The first one's less spicy, right? For L1, for simplicity, we need to basically cement to some degree. We need to decide which ZKVMs to kind of enshrine into, or we should rather. We could have any ZKVM work for proving L1s, but probably for simplicity and consensus, we should probably decide which ones. This is a varied group of ZKVMs as well as L2s and then ETH L1, and I think it's a perfect crowd to ask of how do we decide which ZKVM? There's also the issue of verifier versioning. how do we remove old ZKVMs if they're not keeping up to speed? And I think this is the right group to ask this sort of question from.
So first, I would not advocate again for a single one, but for multiple ZKVM, and I would advocate for enforcing to have multiple proof per block, every block, to be sure that there is not a sequencer providing a proof exploiting a soundness bug, which would be dramatic for the Ethereum network. After, which one to enforce on the protocol, I'm not sure, and maybe Justin, you will speak more about it, but I'm not sure it should be enforced at the protocol level, because if you start enforcing it at the protocol level and you want to upgrade the circuit because there is a soundness bug, then you cannot wait 1 month to have everybody agreeing on this update. So here there is still brainstorming and ideas to find to allow upgrades and ensure that upgrade does not bring some new issues.
Well, I mean, like the execution environment, ZKVM itself is just the execution environment, and we're going to have a lot of debate on that front for sure. And that's totally fine. But I think one thing that is also need to be put into consideration when starting to think about enshrining some kind of a ZKVM-based execution environment to Ethereum layer 1 is how it handles and interacts with the state. Because like we can switch the execution environment pretty easily, but like right now we have all the deployed contract code, we have all the kind of user state that is living in a Ethereum-based data structure, and how do we kind of interact with that? How do we provide account-based abstraction in RISC-V-based VM and the language on top is also a very big thing that are going to have very diverse design. But if that kind of have very diverse design, we're going to have a very bad time for developers to actually adopt that. And however, like I think for ZKVM itself, I'm all for kind of a multi ZKVM proving and stuff. And Justin probably have more heads on that. Yep.
Yeah, so I agree with Florian that especially in the short and medium term, we need this diversity of ZKVMs, and kind of the most sane design that we have right now is that the diversity is actually internal to the operators as opposed to being across operators. So today, we have multiple EL clients, we have GEF, REF, etc. But a single operator is only expected to run one client. The new design basically is that each operator runs, for example, 5 different verifiers, and that's possible to do because you're verifying 5 very cheap proofs. And if each proof takes, 2 milliseconds to verify, that's only 10 milliseconds to verify all 5. And it is kind of nice to have the various clients agree on this list of 5 ZKVMs because it simplifies the gossiping of the proofs. It also means that we're generating a well-defined set of proofs, and and it limits the amount of proving workload that we have to do. Now, how do we select like these 5? I think it's mostly going to be natural selection, whereby
let them fight it out.
There is quite a high bar to getting to real-time proving with the security that we want, at least 100 bits of security, with the diversity that we want as well. And the way that I'm envisioning it is that we take the 5 execution layer clients that we have, we pair them with 5 ZKVMs, and we pair the fastest EL with the slowest ZKVM and vice versa, so that when every pair is at least good enough to do the real-time proving. Now, eventually, if you're willing to think many years into the future, maybe 5 years into the future, that might be an opportunity to pick just one. And the reason is that once we have formally verified a single one, well, we don't really need the diversity, because the diversity ultimately stems from this worry about security. But if we formally verify everything end to end, then we're good. And so here the design criteria actually shifts to simplicity. So if you take the really long view of ZKVMs, at first they were not possible, and then they became possible in theory, and then they became possible in practice, and then we optimized for cost, and now we're optimizing for latency, and then we're optimizing for power, and then finally we're going to optimize for simplicity and for more verifiability.
Okay, I would like to throw in the L2 into the mix. So for us, I think when we look at it from the perspective of L2s, two factors are really important. One is viability, so we want to make profit, so L2 has to be profitable. And the next factor is finality. So when we talk about L1, you have this 12 second for being real time. At L2, this finality is a lot more relaxed. So with this couple of finality and viability, we seek for the VM that performs best, but also costs least. So at the end of the day, we want to make the transaction cost as low as possible and remain viable. So our approach would be more like not enshrining any particular ZKVM, but design our system in a way that we could swap when a new VM comes out that is better. It's much cheaper to run. The hardware is much cheaper, so we are ready to switch. So our philosophy is be ready for changes because everything is going to be obsolete in 3 months.
Yeah, from my L2 level, Arbitrum is targeting the same of like, we want to be able to support different ZKVMs. So it's kind of interesting like breaking it up between L1 and L2s. I do have like questions on that. The one last spicy question, this one's spicy, and Justin, I'm sure you're expecting this to some degree. Is synchronicity a myth? Can it scale to large scale, or should we just embrace async like Web 2 for interoperability? Because the faster ZK proofs get, the faster interoperability you get without having to rely on sort of shared sequencers.
I guess we'll see. So one of the requirements to have synchronous composability across L2s is that they are both proven in real time. And we've only had real-time proving for the last few weeks. So yeah, just give it a chance and see if people want it. The other thing that needs to happen is that there needs to be the right incentives. So if you do adopt a shared sequencer, you lose the MEV, but you gain more fees from composability and traffic and congestion. And so one of the things that's happening in the industry is that applications and wallets and users are becoming smarter and smarter to have the MEV flow back upstream as opposed to leaking to the sequencer. So the less MEV there is that leaks to the sequencer, the more of an incentive there is to connect to shared sequencers to benefit from these network effects. There's still work to do technologically above and beyond the real-time proving. So yeah, be patient. But my thesis is to bet on these trends, one of which is the technology allowing for synchronous composability and the economics every day becoming more and more favorable for synchronous composability.
So I think from a technological point of view, we can achieve it. But after there are other challenges from an organizational point of view, like different layer 2, adopting common standards to make this possible is going to be challenging. We see this today with base rollup. It's a topic that is discussed for a while and that is still being discussed. So I would not bet that in the near future we will have this synchronous composability. I also believe that asynchronous composability is going to improve a lot, and real-time proving could help to make asynchronous composability faster as well. So we'll see if we end up in a situation where it's good enough and the use cases that are left are not of interest for the standard user, but more for someone who is willing to take profit from the Ethereum protocol. And if it ends up this situation, maybe we don't want to put too much effort on somebody who is willing to have some complex transaction to extract MEV more efficiently.
Yeah, so on this point, I think like real-time proving right now is not really real-time proving, So it's a 99% like real-time proving, 95% real-time proving. Means that there are still some bunch of like proof killers, that is the stragglers out there, and kind of we need to really handle that well. So we have to handle that to make it usable for Ethereum layer 1's scaling task. However, 95% real-time proving, 99% real-time proving is good enough for shared sequencer rollups in many cases, and because this provides sufficient amount of like a performance benefit already, and for these kind of, I suspect that in the next year we're going to see some of the ZKVM teams starting to kind of either incubate or even launch shared sequencer based rollups, and the market will decide whether the benefit of added like a non-MEV kind of property will actually kind of win over some other factors of it. But launching a chain itself is very complex, so it's not really about the technology and the benefit of the having or doesn't have MEV, but it's more about like how do you build ecosystem and all that. So yeah.
Motion, do you have anything to add? No, it's okay. No, okay. Let's wrap up.
Cool. I'll just wrap this up with, if you haven't heard the Prover Killer song yet, Google it. It was fucking amazing. Am I supposed to swear? It was fucking amazing. Cheers. Thanks so much, guys.
Okay.